On today's episode of Dora the Explorer, Dora needs your help completing her GN311 homework. Can you help Dora explain the process of transcription in a prokaryote? First, Dora can describe the basics of mRNA synthesis for you. Transcription is the process of turning a DNA gene sequence into an RNA molecule. RNA polymerase is the enzyme responsible for copying the DNA template strand to create a single-stranded chain of common RNA bases in the mRNA molecule. The DNA coding strand is referred to as such because the mRNA sequence will match the coding strand. Keep in mind that thymine is replaced by uracil in mRNA. But Dora doesn't understand how the RNA chain is built. Can you pause the video and think of an explanation? Wow, what a great answer, says Dora. The audience says the template strand is read in the 3' to 5' direction because RNA polymerase builds the ribonucleose chain in the 5' to 3' direction. These ribonucleose chains are held together with phosphodiester bonds created by binding the 3' carbon on the previous nucleotide with the phosphate group located on the 5' carbon of the next nucleotide. mRNA differs from DNA because mRNA ribonucleotide triphosphates contain ribose sugars. Before transcription can begin, the RNA polymerase core enzyme must combine with a sigma factor to create a holoenzyme. This is kind of like how Backpack needs map to be able to tell Dora where she's going on her adventure. The holoenzyme is directed to the promoter region within the DNA sequence because the sigma subunit interacts with the -35 and -10 consensus sequences within the promoter region. Consensus sequences are highly conserved, repeated sequences that serve essential gene functions. The -10 consensus sequence is also known as the Tata box, which is made of repeated adenine and thymine and is especially responsible for sigma factor binding. Dora needs help with this hard homework question. If there's a 5 base pair insertion between the -35 site and the -10 site in the promoter region of the genes that encode the enzyme that produces the amino acid phenylalanine, what do you think would happen? Pause the video and come up with an answer. Wow, my audience is so smart. The audience hypothesizes that the sigma factor would not be clearly directed toward the promoter region, which would hinder the binding of RNA polymerase to the promoter region and slow the rate of transcription. As a result, fewer enzymes would be created, which would result in less of the phenylalanine amino acid and the proteins made with it. Now that initiation has begun, the prokaryotic holoenzyme can unwind the DNA double helix, which creates a transcription bubble. Transcription begins at the +1 site and shortly after the sigma factor is released from the RNA polymerase. Elongation continues with the transcription bubble moving upstream. At the end of where transcription should occur, a transcription terminal sequence in the DNA is made of inverted repeats followed by a series of adenine bases upstream. This results in an mRNA sequence that can base pair within the same strand, forming a hairpin structure which causes the RNA polymerase to pause transcription. Upstream is a string of adenine in the DNA that only binds weakly to the repeating uracil base pairs in the mRNA sequence. This allows the RNA polymerase to dissociate, resulting in the release of a single strand of mRNA molecule. Thank you for helping with me on my homework. Until next time, bye-bye.